Okay, let's finish 7.2. Given the slope and y-intercept on each line, and graph it. Y equals 3x minus 1. Slope is 3. The y-intercept is negative 1. So how does the y-intercept work? Well, you go down 1 from the origin to get your starting point. The b. Your slope is your rise over run. So 3 is really 3 over 1. It's also negative 3 over negative 1, which we'll talk about here in a second. 3 over 1 means positive 3 really means up 3, since it's rise. Run means to the right 1. The other way we can do this is down 3 and to the left 1 for the negatives. So up 3 over 1 gives us other points. You'll notice down 3 and to the left 1 gives us the similar points that are still on the line. So it makes it easy to graph going either way. So whichever way you choose to do it is fine. We're not going to graph number 10. I can leave that to you, but I will get into a y equals form so we know the slope and intercept. 3y equals negative 2x plus 16. So y equals negative 2/3 x plus 16/3. That means our slope is negative 2/3 and our intercept is 16/3. So I can leave that to you to graph. 2x equals y. That means y equals 1/2 x. Our slope is 1/2. And even though we don't see any other number, our b is 0 if there's no number added or subtracted. So we go at the origin, 0. And this is our rise over run. So that's up 1, to the right 2, or as we said, it can be down 1, to the left 2. And you can keep going in that same direction over and over to get the line. Down here it says the graph of a linear function is shown. Identify the slope, the y-intercept, and the x-intercept, and write the equation that defines the function. So our x-intercept is 4, 0. It's not part of the equation, so we'll get that out of the way. The y-intercept is 0, negative 3. Our slope is our rise over run. If we find easy points, looks like we went up 3 and to the right 4. So our slope is rise over run 3/4, which gives us the equation y equals 3/4 x, and then our y-intercept minus 3. Easy peasy from an equation. Let's continue. Other types of questions you might have. Business applications of linear equations. It costs $2,000 to purchase a copier, and each copy costs 2 cents to make. What is the fixed cost? The $2,000 that you have to pay. The variable cost is the 2 cents you pay per copy. So each time you want to make something, it varies based on how much you want to make. So that means the cost equation is always your fixed cost plus your variable cost times x, because you don't know how many pages you're actually going to make. What will be the cost to produce 10,000 copies based on this cost equation? We just plug in 10,000 for x. So that's 2,000 plus 0.02 times 10,000. Now that should really be 10,000 times 0.02 is 1,000 times 0.2, or 100 times 2. 2,000 plus 200, or $2,200. How many copies will it be produced if the total cost is 2,600? Say, well, what's 2,600 equals 2,000 plus 0.02x? Subtract the 2,000. To get 600 equals 0.02x. To get rid of a 0.02, we can multiply by 100 just to see why this is the case. Multiply by 100 to get 60,000 equals 2x. So it moves the decimal place twice. Divide by 2 to get 30,000 equals x. So 30,000 copies. In truth, because we multiplied 100 and divided by 2, it's the same as multiplying by 50. So multiplying by 50 gets rid of a 0.02. We'll do 1 to 14 or 15. Use ordered pairs to find the equation of the line that approximates the data. We have 0, 32, and 25, 76, so our slope, y2 minus y1 over x2 minus x1. That is 44 over 25, which doesn't reduce. Okay, so we have the equation y equals 44 over 25 mx plus b. Now it's nice for us to have this 0, 32 coordinate because then our b is just that 32. It's whatever our value is when x is 0. So not too bad at all. Lastly, let's talk about some tables. Possible word problems. The table below gives heavy metal nuclear waste from spent reactor fuel awaiting permanent storage. So x equals 0 represents the year 1995. Write ordered pairs for the given table. Okay, so since x in 1995 is 0, we have 0, 32. 2000 is now 5 years after that, 42. 2010, 15, 61. 2020 is 25, 10 more years, 76. Those go there in A. Plot the ordered pairs. 0, 32 is roughly here. 5, 42. 15, 61. 25, 76. We plotted them. Do they approximately lie in a straight line? I mean, not perfect, but it's pretty close. Quite close, but not exact. I would say generally yes, though, since it says approximately. Use two ordered pairs to find the equation of the line that models the data. We can use the first 2 points, why not? Generally, though, it's safest to use the first and last. 0, 32, and 25, 76. That's usually the safest bet for approximating. Now you notice we already found the equation of that line at the end of the last page. That was the y equals 44 25ths x plus 32. Use this equation to approximate the amount of nuclear waste in 2015. Now we know how many years since 1995 is 2015? 20. So we'll have y equals 44 25ths times 20 plus 32. Okay, so this is 44 over 5 times 4 by reducing these both by 5. 176 over 5 plus 32. This is 35.2 plus 32, which is 67.2. So it's thousands of tons. And that is all for 7.2.